You can see the slides now, huh? But it is not written anything. Okay. So before going to this class, just I want to ask yesterday's class. So please, any one of them tell what Madam taught yesterday, just within 2 to 3 minutes. Please sum it up. Aditya, can you hear?
Sir,
Whether you attend the previous class? Okay, just
yes, sir. Sir, Madam gave only an introduction about curvature of a circle and
okay, curvature of the circle. What about whether he
curvature and the rate of curvature,
radius of curvature?
radius of curvature.
So
That's it, sir.
okay. So whether Madam gave the formula for radius of curvature?
Yes, sir.
Okay. So what is the relationship between curvature and radius of curvature? Anyone?
Curvature is reciprocal of radius.
Okay, they are inverse of each other. Curvature and radius of curvature, they are inverse of each other. Okay. So before going to the problem, just I will tell the outline of the first unit, okay, differential calculus. So first part is radius of curvature. Second part is evolutes. Third one is envelope. Fourth one is function of two variables, in particular maxima and minima of function of two variables. Maxima and
Sir, your screen is not visible, sir.
yeah, that's why. Okay, thank you. So I'm asking to you already whether my screen is visible or not. I think now it is visible. Huh?
Yes, sir.
Yes, sir.
Okay. My handwriting is not good as Madam handwriting, but you can understand my handwriting. Okay. Maxima and minima. So these are the four major sections in the first unit: radius of curvature, evolutes, envelope, maxima and minima. Okay. So in radius of curvature, there are three subdivision. So radius of curvature in Cartesian form, and then parametric form, parametric polar parametric coordinates, okay, parametric coordinates, and then finally polar coordinates. So please write down, at least take some notes in your notebook. That is the reason I am telling. If you have the writing practice, then you can easily write the offline examination. Okay, I think you know, everybody's know the previous time you studied online classes, you wrote offline exam. I think most of the students are struggling. So the main reason is they don't have the writing practice. But the teacher has more writing practice because we need to write each and everything in the board. So it is better to start to write the notes. Okay. So I think now I'm going to start radius of curvature. So first the Cartesian form. So radius of curvature, formula for radius of curvature in Cartesian coordinates. Formula for radius of curvature in Cartesian coordinates. I think if you know, Madam explain, I think Madam gave the formula. If you know the formula, you can tell which formula you gave. Anyone of you? Pragdish?
Yes, sir.
Yeah, please tell what is the formula Madam gave uh, for radius of curvature in Cartesian coordinates.
Sir, ma'am only gave the formula d phi by ds.
Sorry? Ah,
Sir,
she
curvature
don't.
is equal to d phi by ds, sir.
Okay, okay. So she don't give the formula. Huh? Okay,
Yes, sir.
okay. So
Sir,
yeah, please tell
sir, can you explain from curvature, sir?
from the curvature.
Yeah, sir.
Okay. I will explain from the curvature. For this, I will take the first the PPT and then okay, because using PPT I will explain. Okay, please write. Okay, I think you can see the slides now.
Yes,
Right?
sir.
Okay. So okay, I'll start from the curvature. So you can see the curve here. This is the given curve. Okay, let P be a point on a given curve. P is here. Okay, P be a arbitrary point on the curve, the given curve. Q is the neighboring point. Q is a neighboring point. Okay, so let the arc AP equal to S. The distance from A to P. A to P is S, and the arc PQ. The distance from PQ is small distance. That's why delta S. Let the tangents at capital P. This is a tangent at capital P. This is the tangent at capital Q. Make an angle psi and psi plus delta psi with the x-axis, so that the angle between the two tangents, the tangents at P and Q is delta psi. You can see here. So if if you move the points from P to Q through the distance delta S, through the distance delta S, the tangent has turned through the angle delta psi, this angle. So this is called the total bending or the total curvature of the arc PQ. The average curvature of the arc is defined by the ratio between the total angle divided by the total bending or total curvature. It's a del psi. Del psi, you know that del psi is what? The angle between the two tangents P and Q, and del S is the distance between PQ. So if you approach delta S tends to 0, limit delta S, this is delta, this is S. Delta S tends to 0, delta psi divided by delta S is equal to d psi by ds. This is from the definition of the derivative. So the limiting value, of the average curvature. So this is the average curvature. The limiting value of the average curvature when Q approaches P. So when Q approaches P means delta S tends to 0 is defined as the curvature of the curve at the point capital P. The curvature here it is denoted by capital K, but usually I will call a rho at P is equal to d psi by ds. It's not visible here. Is d psi by. The reciprocal of the curvature is called radius of curvature. So I think on the previous slide we can see that the curvature at the given point P, and here the radius of curvature is the reciprocal of the curvature of a curve at any point P is called the radius of curvature at P, and it is denoted by a rho. So radius of curvature is denoted by a rho. I think here curvature is denoted by capital K. Sorry, I mistakenly told that curvature is denoted by rho, but curvature is always denoted by capital K, and radius of curvature is denoted by a rho. Okay, and rho is the reciprocal of the curvature, so that's why rho equal to ds by d psi. Third definition, center of curvature. Okay, so the center of curvature definition is so you should draw a normal to the tangent like this. Okay, in the previous one, okay, you should draw the normal. I think it is not a straight line. Okay, should imagine it's a straight line. Okay, this is a normal to the tangent at P. So from this point P, the distance, the rho is what? Radius of curvature. Okay, so this is called center of curvature. The distance from center of the circle to the point P on the curve should be the radius of curvature, should be equal to radius of curvature rho. So a point C on the normal at any point P of a curve, distance rho from it is called the center of the curvature at P. At P, that is very important. Center of curvature at the point P. Okay, next, circle of curvature. A circle with the centered C. C is the center of curvature, and radius rho is called, rho is the radius of curvature, okay, and radius rho is called the circle of curvature at P. So here I defined curvature, radius of curvature, and the center of curvature and the circle of curvature. So if you have any doubt in these 4 definitions, you can ask to me.
Sir,
Yeah.
how did we get that formula for radius of curvature?
So here, this formula.
Yes, sir.
Okay. So you can get it in 2 different ways. Okay. So one is here it is explained. So another method I will tell you if possible now, otherwise later. So this is the formula rho equal to 1 plus y1 square whole power 3 by 2 divided by y2. Okay. Now you'll start from here. Start from here. First you should write rho. What is rho? I'll write ds by d psi. So that is the definition of rho. You can write this is ds by dx and then differentiate dx by dc. First, I am going to find this expression dx by dc. So instead of dx by d psi, I am going to find d psi by dx. So for this, tan psi, so that is a slope dy by dx is equal to tan psi from the figure. So tan psi is equal to dy by dx, that is y1, or psi is equal to, what is psi? Tan inverse of y1. Okay, I need d psi by dx. So we need to differentiate psi with respect to x. So tan inverse of x, you need to differentiate tan inverse of x. So what is the formula for differentiation of tan inverse of x? So 1 by 1 plus x square, and then you need to differentiate x. So here, if you differentiate psi with respect to x, 1 by 1 plus y1 square, and if you differentiate y1 with respect to y1 means dy by dx. Okay, if you differentiate y1 with respect to x, you will get y2. So y2 divided by 1 plus y1 square. So that is d psi by dx. So I got d psi by dx is equal to y2 divided by 1 plus y1 square. So, okay. So reciprocal of this is dx by dz. So I need to find ds by dx. Okay. So to get ds by dx, I think it is equivalent to root of 1 plus y1 square. 1 plus y1 square means here what is y1? Y1 is tan psi. So 1 plus y1 square is 1 plus tan square y. Okay. Okay, please write. I will tell you. Okay. So actually here I am going to use the result cos psi. I'll write here cos psi equal to dx by ds. Cos psi equal to dx by ds. Similarly, sin s is equal sin psi equal to dy by ds. So from this you'll get what? Tan psi is what? Dy by dx. Dy by dx. So cos psi equal to dx by ds. Okay. Now I need what? ds by dx. So that is a reciprocal of this. Reciprocal of this is what? 1 by cos psi. 1 by cos psi is secant psi. Secant psi. Okay, you can write secant psi is secant square psi whole power 1 by 2. Okay, 2 gets cancelled. Okay, you can write secant square psi is 1 plus tan square psi whole power half. So this is nothing but I think okay. I think it is visible. If it's not visible, you can tell to me. So tan psi is what? That is y1. So 1 plus y1 square whole power half. So ds by dx is equal to 1 plus y1 square whole power half. That is here. That is this portion. And next dx by dy. Dx by ds is reciprocal of this. Reciprocal of this is what? 1 plus y1 square divided by y2. So if you multiply these two, the numerator is actually 1 plus y1 square whole power 3 by 2 divided by y2. So I think you can get the formula. I think this is the easiest way to get to derive this formula. Uh, okay, but usually the proof is not asked in the examination, but at least you should know for the proof for Cartesian form. Because the reason is from Cartesian form, if you know the proof, then you can easily get the radius of curvature for parametric coordinate and the polar coordinate easily. Okay, I think you understand the proof. Okay.
Yes, sir.
Okay. Okay. Now I will go to the problem. Okay. Problem number 1. Okay. Problem number 1. I will choose problem. Find the radius of curvature. I don't write the full statement. Just I will read and then I will write in the short form only here. If you want, you can write in your note. Find the radius of curvature of the curve I will write here short form rho. Just find rho. So find the radius of curvature of the curve xy equal to c square at the point c comma c. The point c comma c. Okay. So before going to the problem, I will tell the steps. Okay. First step. Okay, you can easily remember. That's why I'm telling you. I'll tell this. First, you should express y in terms of x, and a constant. Second step, find y dash. Third step, find y dash at the given point. Fourth step, find y double dash. Fifth step, find y double dash at the given point. Sixth step, calculate rho at the given point. So if you know this procedure, there is you can easily solve any problem in a radius curvature. It's like algorithm. Solution. The first step should write y in terms of x. So c square by x. Next, you should find y dash. So y dash is equal to minus 1 by x square into c square. And then y dash at the point c comma c. Given point c comma c. So minus c square divided by c square equal to minus 1. Next, y double dash is equal to, if you differentiate minus 1 by x square, we'll get 2 by x cube to c square. Next, y double dash at the point c comma c equal to 2c square by c cube, which is equal to 2 by c. Okay, so we got everything. Next, step number 6. So rho at the given point c comma c equal to 1 plus y dash square whole power 3 by 2 divided by y double dash. So this is a formula for rho. So this is equal to 1 plus what is y dash? Minus 1 whole square whole power 3 by 2 divided by y double dash is 2 by c, which is equal to, this is 2 power 3 by 2, that is 2 root 2. Okay, 2 root 2 into c by 2. 3 by 2. So 2 gets cancelled. The final answer is c root 2 into c or c root 2. I think if you know the method, you can try independently. You can finish it before myself. Okay, and you can tell your answer. Okay, but I will do step by step because I know that I think some other students will follow quickly and some other students will depending upon my class. Okay, so usually I will go a little bit slowly initially, but once you understand the concept, then I will go a little bit fast. Okay. Problem number 2. So please write down the problem fully. Find the radius of curvature. Find the radius of curvature of the curve for the curve, or y square equal to 4ax. Y square equal to 4ax. Find rho for the curve what? Y square equal to 4ax at the point y equal to 2a. At the point y equal to. So if you know the method, you can try. Solution. Okay, so I think here y in terms of x is here, so that's why directly I'm going to differentiate. So if you differentiate this, you'll get 2 into 2y into dy by dx, that is y dash equal to differentiate with respect to x. So you'll get 4a. So I need y dash. Y dash is equal to 4a divided by 2y, which is equal to 2a by y. I need y dash at the given point 2a, so which is equal to 2a divided by y. Y is again 2a is equal to 1. So first derivative at the given point is what? So before going to find second derivative, so here y dash is equal to 2a by y, just cross multiply. So y into y dash is equal to what? So y dash is equal to 2a. From this I have okay. Now if you differentiate with respect to x, the left hand side you have UV method. Y into keep y. If you differentiate y dash, you get y double dash. If you differentiate y, you get y dash into y dash equal to 0. So now directly calculate at y equal to 2, b equal to 2a. Similarly, y dash at 2a and y double dash at 2a. Okay. So y at 2a means, so instead of y, I am going to substitute 2a. 2a and then y double dash, I don't know. I need to find. Okay. Plus y dash square. So y dash at 2a is 1. So 1 square equal to 0. So this implies y double dash is minus 1 by. So here I directly calculated y double dash at the given point. Okay. Y double dash at the given point, y equal to 2a, I found out directly. Okay. Now, I think you know y dash is equal to 1, y double dash is equal to minus 1 by 2a. I'll go to the next page. Rho equal to 1 plus, what is the answer? Any of you got the answer?
So minus 4 root 2 is coming.
Yeah, usually rho is always positive. Okay, take the modulus. So 4a root 2 is the final answer. So divided by y double dash, which is equal to 1 plus what is y dash? Y dash is 1. So 1 square whole power 3 by 2 divided by y double dash is minus 1 by 2a. So which is equal to, this is 2 root 2 to minus 2a. So I need a modulus of rho is 4 root 2 into a. This is the radius of curvature for the parabola y square equal to 4ax at the given point y equal to 2a. So before going to the third problem, now I'm going to give you a note. So using this note only, I'm going to solve the third problem. Please write down the note. As curvature and hence radius of curvature as curvature and hence radius of curvature. Radius of curvature of a curve at any point of a curve at any point is independent of the choice of the x-axis and y-axis. Independent of the choice of x and y-axis. So x and y can be interchanged in the formula for rho. So x and y can be interchanged in the formula for rho. So thus rho is equal to, so you know the formula for rho is usually rho is what? 1 plus y dash. Y dash means dy by dx whole square whole power 3 by 2 divided by d square y by dx square. This is the formula. So now I am going to interchange the x and y, then we get 1 plus dx by dy whole square whole power 3 by 2 divided by d square x by dy square. Plus dx by dy whole square whole power 3 by 2 divided by d square y by dx square. You can use this formula when dy by dx is equal to 0. Sorry, dy by dx is equal to infinity. Okay, you can write here. After this formula, you can write. You can use this formula.
Sir,
Yeah,
sir, in the denominator also it should be d square x by dy square, no, sir?
yes, yes.
Okay, sir. Thank you, sir.
Square xy. Okay. So you can use this formula if dy by dx is infinite at a point. Yeah, point. Third problem. So please write the question. Find the radius of curvature. Find the radius of curvature for the curve xy square equal to a cube minus x cube. A cube minus x cube at the point a comma 0. Point a comma 0. So if you know, you can proceed. Otherwise, you can write for me. A comma 0. Solution. So first you should write the first step, you should write y in terms of x. Y square equal to a cube minus x cube divided by b square. So now if you differentiate this with respect to x, you'll get 2y into y dash. So u by v method. Sorry. If I done any mistake, please point out. Here it is x square. So a cube minus x cube divided by x. So u by v method. If you square the denominator, you'll get square. Keep x in the numerator. If you differentiate the numerator, you get minus 3x square minus, should keep the numerator as it is. So a cube minus x cube. To differentiate the denominator, you'll get 1. So you'll get minus 3x cube minus a cube plus x cube divided by x square. I need y dash, so y dash is equal to, here I have minus 2x cube minus a cube, so take commonly minus. So a cube plus 2x cube divided by 2y into x square or 2x square y. So please check it up to this step. We call this is equation 1. This is 2. Okay, now after finding y dash, what is next? We need to find what? Y dash at the given point. Y dash at the given point, a comma 0. Sorry. So who is ready to tell the answer? Y dash at a comma 0. Nirmal Newton.
Infinity, sir.
Infinity. Yes, correct. Infinity. So this is equal to, so because the denominator will have y, so if you substitute y equal to 0, you'll get infinity. Okay. So if dy by dx is infinity, then you need to consider the formula which I gave already. So we need to find the reciprocal of dy by dx, that is dx by dy. So this is actually dy by dx. I need dx by dy. Dx by dy is a reciprocal of this. So now I'm going to write my next page. So dx by dy equal to, so please check it, minus 2x square y divided by 2x cube plus a cube. We'll call this is equation number. So then we can easily tell that dx by dy at the given point a comma 0 is 0. Because it's reciprocal is infinity means dy by dx at a given point is 0. Okay. Now next I need to find d square x by dy square. So differentiate equation 3 with respect to what?
X.
No, with respect to
Y.
yes, with respect to y. So that's why I'm asking to you. Okay, in the previous case we are differentiating with respect to x. Okay, if you have dy by dx, if you need d square y by dx square, then you should differentiate with respect to x. I have dx by dy. I need d square x by dy square. So you need to differentiate equation 3 with respect to y. So d square x by dy square is equal to, again u by v method. You should be a little bit careful. I need it. So this is equal to, okay, so denominator is the 2x cube plus a cube whole square. Keep the numerator as it is. In the numerator, I'm taking commonly minus 2. So 2x cube plus a cube. To differentiate the numerator, that is numerator is x square y. Again, UV method. Keep x square. To differentiate y, you get 1 plus keep y. And if you differentiate x with respect to y, means 2x into dx by dy. Okay. Minus you should keep the numerator as it is, square y, and if you differentiate the denominator, will have, I'll write here, this is multiplication, not x, so 6x square into dx by dy. Better you should write in your notebook. Okay. Sometimes you may not understand even if you watch this video. Okay. So if you want to again, I will explain again one more time. So just u by v method. So you should keep 2x cube plus a cube whole square. So I will take minus 2 commonly from the numerator. It should take 2x cube plus a cube. The numerator. If you differentiate the denominator, if you differentiate the numerator, UV method, so x square into 1 plus, you should keep y. You differentiate with respect to y, you will get what? 2x into dx by dy minus, should keep x square y. And if you differentiate the denominator with respect to y, 6x square into dx by dy. This is actually plus 0. Now I don't going to simplify further. I'm going to directly substitute a comma 0. Anybody got the answer?
9A for answer.
Final answer.
Yes, sir.
I think nearly it is correct, but not exactly. Okay, we will check it.
3a square by 2.
Your voice is breaking.
3a square by 2.
Money 3a by money and done.
3a square by 2.
3a by 2. 3a by 2 is a correct answer. Okay, but we will. So now, so please watch here. So now I am going to substitute x is equal to a and y equal to 0. So minus 2 in bracket 2x cube. What is x? X is a. So a cube plus a cube into x square is a square plus, there is no need to substitute here because y is also 0. Y is also 0 and dy by dx at a comma 0 is also 0. So this is 0. Minus, again, y is 0. Similarly, dx by dy at a comma 0 is 0. So this is 0. Close the bracket. Actually, this minus 2 is for first expression as well as for the second expression. Divided by, substitute x is equal to a. So 2 a cube plus a cube whole square. Okay. So this is equal to, next step I want to write minus 2 into a square into 3a cube divided by 3a cube whole square minus 2 a square to 3a cube divided by 3a cube whole square. Now I'm going to cancel 1 3a cube. So minus 2a square by 3a cube. That is nothing but minus 2 by 3 into 1 by a. So d square x by d y square at the point a comma 0 is equal to minus 2 by 3a. Minus 2 by. Okay, now we need to substitute everything in the formula row. So 1 plus dx by dy whole square whole power 3 by 2 divided by d square y by dx. Sorry, d square x by dy square is equal to 1 plus 0 whole power 3 by 2 divided by minus 2 by 3a. The final answer is I need a modulus of rho is 3a by 2. This is the final answer. Okay. Okay, now I think time is nearly 4:10 now. Okay, I will give some problems to you for practice, and then we will discuss remaining problems in the next class. Please note down the formula, and the problems, and then if you get the answer, you can post in our group. Once you got the answer, suppose if you have any doubts, first you send to me, and then I will check it, and then you can post. It's up to you. So you should decide. Okay. So problem for practice. Y equal to e power x at x is equal to 0. So you should write commonly, find the radius of curvature for the following curve. For the following curve, here the point is y is equal to 0. Next problem, y is equal to e power root 3 into x at the point x is equal to 0. Sixth problem, y equal to log of secant x at any point on it. At any point means at a general point. At any point on it. I think you will try these three problems. Okay. Also give the seventh problem. If possible, you can try. Otherwise, we will discuss tomorrow. I think 4, 5, 6, you can do it easily. Show that the curves. Show that curves y equal to c into cos hyperbolic cosine of x by c and x square equal to 2c into y minus c have the same curvature not radius of curvature, same curvature. If they have the same curvature, automatically it has the same radius of curvature, have the same curvature at the points where they cross the y-axis. Where they cross the y-axis. Okay. I think these 4 problems is enough for practice now. Okay. Okay, one more problem. 8. Find the radius of curvature for the curve x cube plus y cube plus y cube equal to 3a xy. The point 3a by 2 comma 3a by 2. So this is enough. Okay. So actually I solved only 3 problems, but I gave 5 problems. The reason is you should try more problems, then only you can write in the examination also. Okay. So surely I will not do it again 4, 5, 6. Okay. But I will do it 7 day if you have any doubt. But I will do it 7 tomorrow. Okay. You will try. And if you get the answer, please post in the WhatsApp group. Okay. If you have any doubts in today's class, you can ask me. I will try to send the, I think I already sent the syllabus copy to you. I will send the book through WhatsApp. Maybe today or tomorrow I will send the book. Okay, thank you. If you have any doubts, you can ask to me. Otherwise, we will meet in the next class. So what is the next, when is the next class? Tomorrow or day after tomorrow? I don't know the timetable. Okay, I will check it. Okay, thank you.
Thank you, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Please tell.
Sir, should we always take the constant value with variables, sir? We shouldn't leave it aside.
Where you are asking exactly, please tell.
Sir, in every question, so you are taking only y in
Other,
one
yes,
remaining.
yes. Yeah, remaining thing. Yeah, yeah. Because I need y dash. Okay.
Okay, sir.
So that's why I'm writing y in terms of x and the remaining thing constant separately. So then only I that is the easiest way you can find the y dash. Okay,
Yes, sir.
even you keep y dash left hand side. Okay.
So actually, I differentiate the question as same as this without even changing the x to other side
Which
or
which which problem? Which problem?
last problem, sir.
Third problem.
Yes, sir.
Xy square equal to a cube x. Yeah, you can here then you can do it UV method.
So
Okay.
then I'm getting numerator as 0, sir. d2x by dy square.
I should do it carefully. Okay, you need to check it. Actually, x into 2y into y dash. Okay, otherwise you take a photocopy of your solution and send it to me through my personal WhatsApp. But
Okay.
your handwriting should be little bit neatly. Okay, otherwise it is very difficult to understand. Okay,
Okay,
write
sir.
neatly and then take a photo. If possible, try to send it as a PDF. I will check it. I will tell you where you done the mistake.
Okay, sir.
Okay, thank you.
Thank you, sir.
Sir, if the curvature is negative, then the curve is concave downward.
Curvature is negative.
Yes.
Mm, when the curvature is negative, what you're asking whether whether the curve is
Even,
concave down? Huh?
yes, sir. Inverted down, that like.
Yeah, yeah, it should be like this only. But
Okay, sir.
usually we don't take you don't consider, we are considering only the positive value of the radius of curvature. But if it is negative, it should be concave.
Okay, sir.
Okay, thank you.
Thank you, sir.
Thank you.